Good afternoon, everybody. Distinguished guides, honorable VC members, respected examiners, all the eminent personalities here. I, Garima Sharma, Ph.D. student from IIM Visakhapatnam, here to present my Viva for the work done for my PhD thesis titled The Long-Term Morphological Development of Kakinada Bay. The long-term morphological development of Kakinada Bay was done integrating the two techniques, remote sensing, GIS, and numerical modeling. My study is an integration of two techniques to predict the morphological development of Kakinada Bay for next 100 years, from year 2019 to year 2119. In the integration of this study, remote sensing has helped. It's being used to validate the data, validate my study using the past data. I have studied Hindcast modeling for validating my model. I have analyzed the historical images, the past images. Then, using numerical modeling, first I have handcasted and I have validated my data. Then, numerical modeling is used for future development, for prediction of future development of the Kakinada Bay. That is from 2019 to 2019. Now, for forecasting of morphological development of Kakinada Bay, three variants have been used. Three simulations have been run for 100 years. One is for tides known as forcing. Second was tides and waves coupled model. And third was introducing the climatic effects. So, tides and waves coupled with the decadal rising sea level. So my objectives are prediction of long-term morphological development of Kakinada Bay using numerical simulations duly validated with the remote sensing images. And second, to identify the effects of incremental addition of the environmental forces like waves and sea level rise. My scope of the work has been divided into three parts. First of all, quantification of shoreline changes inside the Kakinada Bay using remote sensing imageries and quantifying them using geographical information systems on DSAS mode. Then second, numerical simulation of the hydrodynamics and sedimentation inside Kakinada Bay using DEL3. Third, once my hydrodynamic model was validated, then morphological model was formed in the DEL3D, and 100 years of development of Kakinada Bay was predicted using DEL3. So my study attempts to answer the following questions. First of all, how reliable are these numerical modeling results when we are predicting the morphological development? Secondly, what are the crucial processes that are involved for studying the long-term morphological development? Then, can climate changes effects be predicted over the development of the region for using long-term morphological model? So my study area is Kakinada Bay. Kakinada Bay is situated in the East Godavari district of Andhra Pradesh. It is a low-lying area with an area of 132 kilometers square. Kakinada Bay is predominantly known for the second largest mangroves on east coast of India, that is Koringa mangroves. Kakinada Bay has a very unique morphology. It is on the eastern side. It has naturally formed sandspit, which acts as a barrier from the sea inside the bay. Then, at the southern part of the Kakinada Bay, Koringa mangroves exist. And on the western side, there are mangroves from the southern extent and the Kakinada port and the city. This area is influenced by semi-arid climate with average rainfall of 1040 millimeter per annum, and annual mean temperature is 20 degrees Celsius. So first, I'll start with my first scope of work, that is quantification of shoreline changes inside Kakinada Bay using remote sensing and GIS. For this, since the shoreline of Kakinada Bay is predominantly the Koringa mangroves, hence Garima mangrove shoreline was delineated using the remote sensing images, for which NDVI was taken as mangrove seaward edge, and it was delineated for years 1977, 1988, 2000, 2006, 2013, and 2019. This was performed on Digital Shoreline Analysis System DSES. For this, the shoreline was divided it was 20.5 kilometers stretch of the shoreline, for which 41 transits was casted at a difference of 500 meters. Then three statistical parameters were used for analysis of shoreline changes. First, net shoreline movement, that how much distance the shoreline has accreted from the base point to the final year. Second was the end point rate, that is the how much rate per year the shoreline has accreted. Then linear regression rate, that is from the final to the from initial to the final, what is the linear rate. So these are the details of the satellite imageries that has been used for mangrove shoreline delineation. These are the Landsat images with different bands, with different acquisition time, and the tidal height. So this figure represents the shoreline, mangrove shoreline, which is shown from 1977 to 2019. And these are the transects which have been casted at a distance of 500 meters, and it is showing how much accretion has occurred and how at the western side of the bay from transit 2 to 25, 26, and then thereafter at the southern part of the bay towards the eastern side near the shoreline spit, very slight erosion has occurred. So this is the endpoint rate and linear regression rate, which gives us the rate of shoreline movement that has been calculated by dividing the distance of shoreline by the time between the newest and the oldest, that means from 1977 to 2019. And the graph suggests that from transit number 0 to nearly 30, there has been considerable accretion that has occurred, and from 30 to till 41, there has been slight erosion that has occurred over the period of time. So there are different rates. Accretion rate has been 14.38 meter per year, linear regression rate 14.79 meter per year. Major accretion has occurred at transit number 24, which denotes there is a visible progression of mangrove shoreline from the previous point to the newest from till 2019. And maximum erosion has occurred at transit number 33. So this is the net shoreline movement. It is denoting the total distance which has been moved by shoreline. So out of 20.5 kilometer stretch, 15 kilometer stretch is under accretion and rest under erosion. So clearly the western part of the bay is showing accretion, and there is very slight erosion at the eastern part of the bay. Once the quantification of shoreline changes was done, numerical modeling was done for simulating the hydrodynamics and sedimentation inside the bay using DELF 3D model. So numerical modeling is basically application of set of mathematical equations which uses certain equations which perform the digital analysis of a physical process and gives a solution that how it is happening. So DELF 3D is a computational fluid dynamics model that helps in studying hydrodynamics, sediment dynamics, wave dynamics, etc. So in this study, DELF 3D flow and wave modules were used. So this is a numerical model for Kakirara. It is a rectangular orthogonal grid using spherical coordinate system, and the grid size near the shoreline changes are 10 meter, while inside the bay it is 58 meter by 60 meter. So these are the data which were collected for the calibration and validation of the model. Type data was obtained from Kakirara seaports. waves, currents, and sediment analysis was done using fieldwork for these different areas. And various numerical parameters were tuned for calibration of the model, like flow step, Chelsea bottom roughness, coefficient, eddy viscosity, etc. So this is the flow model validation. For calibrating the model, various parameters were tuned so that model represents the field work, so that observed values, observed current values, and observed water values, sediment values match the model simulated data. So the model was run for a period of September 2011, and water level, current velocity, directions were validated. Astronomical types were used as input for the model, and regression coefficient was obtained as 0.945. Then similarly, current speed and current direction were compared. Then thereafter, wave parameters were compared for the observed and model data for Kakinada coast. So these are the waves that are being simulated using NIOT model data. Waves were extracted at the model boundary, and they were compared at the model boundary, at the mouth of the bay, and inside the bay, which resulted as very less wave heights were coming inside the bay, which in the model, in the graph we can see the green line shows that the wave heights inside the bay is very less, which led to take the decision that since waves are very less which are coming inside the bay, hence first variant of this 100-year simulation was taken where only tides were taken into consideration. So this is the sediment. Then thereafter sediment model was calibrated. For this, since Kakinada Bay has cohesive sediment silt because of high silt clay and organic matter, and bed shear stress was based on Benjamin roughness parameter. This is the suspended sediment concentration validation. Thereafter, third scope was taken, which is prediction of long-term morphological changes of the Kakinada Bay. So, as I had mentioned earlier, 3 variants have been run: tides alone, tides and waves combined, tides and waves combined, along with decadal change of sea level rise. So now, after validation of flow model and wave model, morphological model was formed, in which waves, tides, currents, sediments with dynamics are analyzed, updating bathymetry after simulating the changes of the region for a particular period of time. Now, since long-term morphological development for longer years, like century, 50 years, 70 years, 100 years, more than that, we need a lot of computational time, error, and computational time, facilities, and human effort, which is very difficult. So, in order to reduce the computational time, efforts, and time constraints and facilities and high RAM requirement, morphological modeling, there have been few various methods have been introduced, like model reduction, input reduction, and morphological acceleration methods, which help in reducing the computational time. First of all, model reduction, where only significant processes are used as input. Like for my first variant, I have included only tides, as waves coming inside the bay are very less. Secondly, input reduction. Input reduction means instead of using the full climate, like full tides, astronomical tides, or full wave climate, we are schematizing the full climate data into the representative data, which would represent the full data. So representative tides and schematized waves were formed. Then acceleration method. Morphological acceleration methods were used, which were multiplying the bed change level and the updated bathymetry. So first of all, tides alone, it was simulation was performed, for which morphological tide was formed as input reduction method. So morphological tide is a representative tide which produces similar results as obtained by the astronomical tides, and it was formed by the astronomical constituents M2 and C1 where period of entry in C1 were kept as 745 minutes and 1490 minutes. And an amplification factor of 1.3 was multiplied to M2. So now whether my morphological type is working well, is it representing the actual astronomical type? So for this, validation of morphological type was conducted. With this is the current speed which has been compared for using morphological type and astronomical type. Thereafter, morphological acceleration factor was found. Morphological acceleration factor is also called as MORPHAC, which is used for faster computations, as it multiplies the bed levels computed for the hydrodynamic type steps by the factor. So with higher MORPHAC values, our runtime decreases. So with now again, to arrive at an optimal MORPHAC values, some sensitive analysis were performed. Here, Brayer-Skill score was used, which compares the predicted simulated bathymetry with the brute force or benchmark simulation. Brute force or benchmark simulation is when we are simulating the bed level changes with the full climate and with no morphological factor. It is a full climate with MORPHAC 1. While accelerated simulated simulations, they use some morphological factors and they're using morphological types represent and schematized waves. So BSS provides a quantitative analysis of skill of the model, where skill is the accuracy of prediction, where now BSS with higher value 1, it implies that predictions are very good, and these are quite identical to the benchmark simulations. So I had taken MORPHACs 10, 20, 30, and 40, and have compared the simulations for 6 transects casted inside the bay, 3 from the from the west to east direction, and 3 from the north to south direction. The resultant bathymetry was used to extract the depth, the bathymetry of those points, and they were compared using the Brayer-Skill score. So for these 6 transects, it was found that MORPHAC 30 gave a very good results. So MORPHAC 30 was used for Hindcast and forecast simulations. Now after forming morphological model using morphological types and morphological acceleration method, factors, morphological model was validated. Morphological model was validated by comparing the accelerated long-term morphological simulation with the brute force simulation as a reference. So, brute force simulation uses the harmonic morphological type with morphological factor 1. It was run for 1 month, where no acceleration factor was used. While for comparison of morphological model, acceleration MORPHAC was used for 30, and the results were compared for MORPHAC 1 run for the whole period, and MORPHAC 30 run for the constraint period. Again, the resultant water depth was compared for all the 6 transects casted in north and south direction and west to east direction. And the results were found in good agreement, as these are presented in the statistics table. The regression coefficient was more than 0.9, the bias and the standard deviation. So thereafter, Hindcast modeling was performed. In order to see how the model is performing, Hindcast simulation was run, that is modeling the previous what has already happened. So here from year 1977 to 2019, from 1988 to 2019, Hindcast simulation was run, where bathymetry of 1988 was taken as input, and accelerated model was run for 1 year, representing with MORPHAC 30 representing 30 years. The resultant bathymetry was obtained as simulated bathymetry for year 2019, and the result is compared in this image. This is the image for a remote sensing image of year 2019, where simulated shoreline of year 2019 is compared with the satellite imagery of year 2019. Thereafter, forecast simulation was performed Initially it was performed again with MOSFET 30 for a period of 30 years from 2019 to 2049. Now this time, initial bathymetry was taken for 2019 year, and after the simulated bathymetry was extracted for year 2049, and it is compared on the satellite imagery of 2019, and there are two shorelines are compared for simulated shoreline of 2049 and shoreline for 2019, and it is showing that considerable accretion. It is predicting considerable accretion and near the western part of the bay on the upper side. Now, the overall shoreline movement, which is the predominant accretion is occurring, it is predicting 500 meter of change in next 30 years in this part. So thereafter, statistical analysis was performed again using EPR and NSL for simulated shoreline of year 2049. Again, 241 tons this was casted for the 20 kilometer of shoreline, and this is the EPR and NSM found for this period. It is in the similar trend as it was earlier shown during quantification of the shoreline, that there is considerable accretion at the western side of the bay and there is slight erosion at the eastern part of the bay. Now, in order to have confidence in our model, statistical comparison was performed with the numerical modeling results and the remote sensing modeling results. So in this, endpoint rate is compared for the Hindcast simulated shoreline obtained for year 2019, and it is compared with the satellite shoreline for 2019. And regression coefficient has been found as 0.99. Thus, it gives us confidence, yes, our morphological model is working fine, and there is reliability over the predicted results by our morphological methods, which answers our question number 1. After this, 100 years of simulations were performed from year 2019 to 2019. Now, second variant, after completing simulation with tides alone, the second variants come into play, which is forecasting modeling with tides and waves. The coupled model was formed, which is the online coupled model where the updated wave data, wave simulation runs with the initial forcing conditions, and wave generated results are given as input into the flow model. Now again, for model reduction, so again for input reduction, we are schematizing the data. Like earlier we have for tides, we have formed the morphological type. For waves, we are forming the representative waves, that is schematization of waves. We are reducing the full wave climate into the representative wave, which is done using for choosing the method, like which wave schematization method should be used. I have compared energy flux method and potential sediment transport approach. So I will discuss energy flux method. So energy flux method schematizes the waves on the basis of wave climate. It calculates the energy of each wave bin. Now full energy wave, the full wave climate is divided into number of directional bins and wave heights. I'll explain it here. So this is my wave data. Here HS represents the significant wave height, and this x direction is the wave direction. Now we are dividing it on the basis of wave direction. We are calculating the energy into 3 parts. So this is the division of the energy, E by 3. Now thereafter, after dividing this data based on wave direction, we are dividing it on the basis of wave heights. So again, energy divides, earlier the energy which was divided into 3, now since we are again dividing it into 3 further bins, it is every bin has E by 9 energy, like means every wave period which has been every bin which has been created, equal energies presented in all the bins. Now, potential sediment transport approach. It uses the how much potential of sediment transport every wave period which has been schematized would have, and it uses the search equation. Then thereafter, right now we have used the full climate. Now application of seasonality has been studied, that whether full wave climate should be divided, or should we divide our waves on the basis of seasons. So now, since the area is characterized by southwest monsoon and northeast monsoon, where waves approach from the southwest during March and October, and from the northeast during November to February. So now this full wave climate is divided into seasons. Since major part is during March and October, so wave directions were divided into 5 bins with a difference of 36 degrees between each wave class, and for period of November to February, 4 directional wave classes were formed with a difference of 28 degrees between each class. Thereafter, morphological acceleration factor was formed. For tides alone, one constant morphological acceleration was formed, which was Morphet 30, while in coupled model of tides and waves, variable morphological acceleration factor has been formed, which is based on the probability of occurrence of that particular wave height wave period of that wave class which has been formed. So morphological acceleration factor is definite for each representative wave class, matching their duration. So Morphet is calculated as if suppose one wave period, it occurs for a few days in a year. So Morphet is calculated as number of days into 24 into 60, that is 24 hours and then 60 minutes, divided by 745. 745 is the computational time between wave period and flow. Similarly, if it occurs only for a few hours in a year, so number of hours into 60 divided by 745. So now, which method to choose? Energy flux method without seasons, energy flux method with seasons, potential sediment transport approach with seasons, potential sediment transport approach without seasons. So for choosing the most appropriate wave schematization method, comparison has been done after simulating the Hindcast modeling for 30 years from 1988 to 2019. I have simulated the period, this data, and the results were compared by comparing the shorelines, that how shorelines are accreted, how shorelines have changed using these two methods with and without seasons. Breyer's skill score, which again compares the predicted shoreline with the benchmark simulation, and then how much volume has been changed in the bay. So these are the shoreline changes which has been formed using, there is 1988 shoreline, 2019 benchmark simulation shoreline, and then we have energy flux method with seasons, without season, potential sediment transport approach with seasons and without seasons. So thereafter, the results were compared using Breyer's skill score. Again, like 6 transits were casted, and the BSS scores are presented in this table. Thereafter, volume of bay was compared with a brute force simulation where it was found that the potential sediment transport approach with seasons is very near to the results are very much near to the brute force simulation results. So hence, potential sediment transport approach with seasons was the wave schematization method which was used to form the wave climate data, the schematized wave which was used as the input in the morphological model. Now, third variant was simulated for next 100 years. In this forecast modeling with tides, waves, and mean sea level rise was taken into consideration. Seeing the future, like sea level changes, change in climate data, how much sea level rise will affect the morphological changes in the bay. So decadal sea level changes were given as input in the flow and wave coupled model. So the NASA sea level projection tool, it was used to download the sea level changes for every decade, and the shared socioeconomic pathways scenarios are there, in which 7.0 was chosen. It is medium to high reference case where no climate policies are added and high aerosol emissions have been referred to. So this decadal data was available on the site. So this has been incorporated in the model. So after this, these simulations were run. Morphological modeling results were compared for all 3 seasons, where planimetric variations were compared, volumetric variations were compared, shoreline changes, depth changes, and suspended sediment concentration changes were compared, which were obtained after 100 years of simulation for all 3 variants. So this is the planimetric variations obtained. The first image shows the initial bathymetry for year 2019. And the legend shows the bathymetry changes, the bathymetry from 0 to 2 meters. So, so these are the graphs which shows that with tides alone as forcing, there has been the bathymetry has decreased, which shows the deepening of bay has occurred. With waves and tides coupled, this is showing there's depth has again increased, and with sea level rise, we can see with the increase in water as sea level rise is increasing, water volume is more. So these are the shoreline changes. The first graph shows that only tides as forcing. Second, tides and waves combined, and third, tides and waves with MSL rise. These are the volumetric changes. It shows the volume. The volume has changed. The tides alone, there is there's a slope. With the flow wave volume, there is a steep decrease in the volume. Thereafter, the bay has attained a quasi-equilibrium stage, and thereafter it is increasing again. Then flow wave MSL volume, and this it is shown that the sediment volume is still higher with the increase in water volume, the increase in MSL. Now these are the SSC variations along the transects, which are comparing the tides, all 3 variants, tides alone, tides and waves combined, and the mean sea level. And the results are compared for the 3 transects. So it shows that with the first graph, that is for the transect 1, from the west to east direction, it shows how SSCs are compared, have changed. So for tides alone, sediment concentration at the top of the bay has reduced, while for flow and tides coupled model, the sediment concentration is increasing, which is showing that inclusion of waves, the longshore sediment transport is bringing the sediments at the mouth of the bay, hence sediment concentration is increasing. Then third is the mean sea level rise incorporation in the model. So it shows that again sediment concentration is very much higher at the top of the bay. Then second is the transect number 2, which is inside the bay, T1, T2, T3. So all the transects along the transect 2, it is showing the flow level for only flow. There is a steep decrease in the sediment volume. For flow and wave, for the coupled flow and wave model, sediment concentrations are very less inside the bay, which shows deepening of, which shows sediments having eroded. And the third is the MSL level. Again, the concentrations are less. And at the transect number 3, T3, which is from north to south direction, the transect is casted from north to south direction. It is showing that from the mouth of the bay till the southern part of the bay, sediment concentration is decreasing. So this shows that the action of waves and tides bringing sediments down. So sediments are decreasing at the southern part of the bay. So this is the depth variation. The first graph is for T1, which is the transect casted at the west to east direction at the mouth of the bay. It is showing that depth is changing. For MSL, depth is higher as water level is increasing. Thereafter, as it is moving towards the spit, there is there is Kakinada channel, hence the depth is higher. Then at uh, transit 2, which is inside the Kakinada Bay, so it is seen that depth is decreasing, which is showing that the deepening of the bay has occurred, the depth is decreased, and then transit along the transit number 3 from north to south. So again, we can see it is starting from the top. The higher values are showing the channel, Kakinada channel, and thereafter again the depth is lowering down along the transit. So the comparison of morphological model as compared for these three variants show that wave action, we have compared the model reduction, input reduction, and MSL level changes. So inclusion of waves with the flow model, it shows that wave action has brought sediment inside the bay as an action of longshore sediment transport. The action is predominant at the mouth of the bay as considerable sedimentation has occurred at the mouth. Then higher suspended, no significant changes have occurred at the southern portion of the bay by the addition of waves, and addition of sea level changes in the model has resulted in increase in the depth and volume of the bay, and addition of wave current interaction has effect in bringing out the complete mechanisms of the long-term morphological evolution. So the conclusions drawn to the research questions: first, to which extent the long-term morphological modeling results are reliable. So as we have compared our model by performing Hindcast simulations where previous from 1977 to 2019, the resultant bathymetry has been compared using Brier's score. So reliable results have been produced, and the models are validated using tides alone, tides and waves combined with schematized waves with energy flux method, with sediment transport method, and Brier's score. The second question is, which are the most crucial hydrodynamic forcing in the long-term morphological development of the region? So the two approaches were investigated as incorporating the most important processes and the essential physics. So for the most important processes, means only tides were considered, as wave actions inside the bay was very less, and then essential physics means tides, waves, MSL, everything was included in the morphological simulation study. So here addition of waves has led to complete mechanism that has been studied for the long-term evolution. And the study concludes that incorporating underlying processes in numerical simulation is the most important and most appropriate approach, as it gives insight to the perfect behavior of the system. Then third question, can climate change effects be predicted on the morphological development of any region? Yes. The third set of simulation has incorporated the decadal mean sea level rise, and it has shown that how change in sea level has changed the bathymetry level, suspended sediment concentration level, the depth level. So the study achieved its objective as the long-term morphological development of Kakinada Bay is predicted using numerical modeling, which has been duly validated using the remote sensing data. Then numerical model Hindcast simulation shoreline results are compared with the shoreline derived from the satellite imageries and are compared using Brier's score. Then 100 years of morphological development from year 2019 to 2119 is simulated and compared for all three scenarios: tides alone, tides and waves combined, and tides and waves with MSL rise, and the incorporation of environmental forces, tides, waves, and sea level rise is optimized as we have seen the incremental changes with all the three scenarios over 100 years. Thanks.
We have with us Dr. S. Jayakumar, scientist and professor in the National Institute of Oceanography, Goa, as an external examiner. Also, Dr. Basantakumar Jena, senior scientist in the National Institute of Ocean Technology, for external examination. So, yes, Dr. Jayakumar.
Thank you, Professor Siva. Garima, my task is to ask the questions of the external examiners, both the reviews. If you have made that answer some questions, please go through that. Basically, I have gone through all these things because I got ready with let's say questions and answers. Yeah, so that's what let me. No, let me tell you when to do that. Right, so the 7th point you are saying major accretion found in plants at 25, whereas in your presentation you said 24. Was it a typo or it is something completely different?
It's 25.
So in your presentation you said 24. 25 said 24. Yeah, can you just tell what is the meaning of the current number, why it is used?
Yes, sir. So, current number, it indicates the numerical stability of the model, like how much time steps for each time period that flow change will transfer from one grid cell to the other cell. So it determines the stability of the model. So that model should not flow, and that is the hydrodynamic time steps. It should be less than one.
Yeah, but I remember mentioning in your thesis that it is more than one.
So, it should be less than one either. So, and it is 0.8 for the study.
0.8.
Yes, sir. And 30 seconds were taken as time step for this study.
Remember to give us explicit scheme or implicit scheme in your depth read. It's a FEM.
Yes, sir.
It's a FEM.
No, it's a,
if it is a DM, then it has to be less than 1.
yes, it's less than one, sir. It was 0.8.
So major thing was what was the model, NIOT model was used both for boundary input as well as validation. Right, the question was when you use the span model, you have taken input data as the boundary from NIOT.
Yes, so the initially to see how much wave variations are inside the boundary, the wave data was extracted using NIOT wave model, and it was compared with the observed data for the Kakinada wave data. So once we got how much waves are entering inside the wave, thereafter the observed wave data for the Kakinada wave was taken as input for wave standardization. So, so NIOT wave model was used for comparison of the observed wave data. So it was taken as input boundary condition.
Confusing because when you say model, we are giving an input and then we are taking a point and then comparing with
Observed data.
details of observations is missing because if I read that the results of NIOT atlas have been taken as a basis for comparison of data in the absence of other source of data. So there is a contradiction there. You are saying previous time you are saying number of locations with observed data, and next time you are saying absence of other sources. So I felt that there is some contradiction. So we just negate that part.
This is the style I think is presented in the PPT. What is written here is totally contradictory. That is right. She has compared with the NIOT wave data for the input of her model. But
the absence you remove.
Yeah.
Okay, that's
Yes.
only thing. 22, I think that's gone because we saying the question is that why there is a large difference between the model data and the field data when it comes to current. Rates was okay, but then current was something in the issue. Okay, next one. Yeah, so morphological side, there was a question that you have used morphological side and then you made some factor so that other physical terms can be incorporated. That is how the morphological side comes in. The question was whether that morphological side incorporates all other tidal constituents effect.
So generally M2 and the M2 and C1 are taken as representing the full wave climate. The tidal
I will
constraints.
explain. If you have to use the real tidal simulation, you need to use up to 150 constants. If you are one-to-one to nature. But here the effect of such tide is getting reproduced with lesser constituents. So in this case, the real tide plus morphological tide are supposed to yield identical end results. Like one cycle you change. There's one small delta x difference is there, the inequality. So now using either only two constants, you will still reset to small inequality. The inequalities are equal. That's an argument.
Basically, you should understand what he said.
Yes.
Okay, you can understand that question becomes very simple. Okay, so the term of brute force is creating a problem. When you say brute force, I want this to deform, so I'm using the force. Okay, that's a brute force in physical terms. But then you are representing that as a benchmark simulation wherein you are doing all the physical processes and getting the output. That is not a brute force. Okay. The terminology of brute force is you are forcing something.
Maybe she borrowed it from the literature. So what we essentially want to say is a one-to-one simulation.
So that's what the examiner asked. What do you mean by brute force? So I understood, but still I'm.
Yes. So since in literature there were benchmark brute force, two terms were referred to. So
Maybe brute force you can avoid because it conveys for an outsider, a domain outsider, it might convey a wrong thing. Benchmark simulation is a better word.
You have used the decadal sea level changes.
yes.
For which IPCC scenario this data was which one you have taken?
Sir, it was extracted from 6 IPCC model and scenario number 7.0 was taken, in which it was chosen as it denotes as no significant climate policies are applied and higher erosion emissions are included in that. So since in general there will not significant monitoring of the climate laws, environmental forcings would be applied, and there are definitely higher erosion emissions. So this 7.0 was taken as
Is there anything severe than 7.0?
There is like no emissions at all, and then higher emissions with climate.
You have because you said 7.0. Is there anything 8.0, 9.0, 10.0? Are you aware of that?
Yes, I had seen, but I had gone through all the
Either the worst possible case scenario or something worse can happen.
So this was the moderate one, and I think there is one more severe.
That's what you want to.
was
It's
there.
a moderate one.
The moderate one.
It's not in the extremes.
This is the moderate ones.
No, this is not moderate. This is one step below the extreme. Okay, 8.5 is the extreme as of now. 2.6 is what's the moderate. 4 is the moderate. So 7 is one below the extreme. So basically, when you put those numbers and being in climate change, I think we need to know what is the maximum. What is the
Is there a reason to select higher than moderate?
So higher than moderate, so since so many activities are going on, so not much enforcement of climatic laws would be applied and or can be followed. So hence, lesser than one step higher than moderate and one step less than extreme was chosen, taking the applicability practical application.
Not the middle, so she's on the
Okay. But you say that policy changes are not applicable.
Yes.
That is unlikely, no? That somebody else policy change can happen.
So, but for so that can take care of the entire but very like small, between small. So that's why.
put in there. Yeah, one thing with this output of the simulation was the spit was moving inside into the wave. Right, that was one. And we said 15 meters is the extension, it's not the depth.
It is moving towards
The plan
moving
will
around.
be different.
Yes, sure.
Okay, so it's only 15 meters change the question is when you use this model, and if you assume that there is no sediment movement out of the model or coming in, that means the mass is balanced inside. Everything happens inside. But here we are seeing that you have given some input
From the boundary.
from the boundary, and then you are allowing the sediment to go on. This creates a problem. The problem is that if I give 1 millimeter cube per second as input, that much is coming in. Okay? But we don't know how much goes out. This input data is again question mark because we have not seen anything that this is the quantity of sediment coming into the system. Okay? I think it's not clearly mentioned.
No, but he has given a
0.02,
steady state sediment input on the boundary, right?
Yes,
It's not the time varying.
that's the steady from the model.
Even when you say steady state, what is that value at the boundary?
Okay.
If that changes, your dynamics will change.
Yeah. Like, tell us.
Right. So that's the reason the question came in that when there is, whether the mass balance is not right. In this, I want to go to 94.
Page number
No, no, this one. 100 years have been studied. So when you say 100 years, it is not 1, 2, 3, 4, 100, right? So 19, 39,
On 10 years, yeah.
every 10 years or every 30 years, right?
10 years, yeah.
Every 10 years. The total duration is 100, but every 10 years level. When you take 10 years, the morphological factor is 30 again.
30 when only tides are considered. 30 is the constant morphological factor when only tides are taken into consideration, and when waves are included and emission values are included, then variable morphological acceleration factor as per the wave periods are
Okay,
given.
30, 30, then I'm getting only 90. 30, 30, 30.
Yes, sir. So in that case, the flow, the simulation period, that is less, so that giving 30 as input, it represents only 10 years. Like it is 1/3 of the simulator, 1/3 of the year that has been simulated as the full time period, and with morphic 30, which so that it gives us 10 years of result.
Basically 3.33 you have taken
Months, yes.
Yeah, so duration.
Yes.
So that's the question which I had. So in this elaborate that it will not match. That's what you were saying.
So in the morphic calculation, the formula which has been given, it shows that PC, that is the probability of occurrence, and it has been given that it is the duration of that particular wave class in a year. It can be the period, the wave class which has been obtained using the schematization. It can be few hours, it can be month, okay, like this much hours or this much days it is formed. So that is the occurrence, and that is given in the formula for calculating the morphic. Now, addition of these morphic, since these are the representative wave height, the calculation will not give us full year because it is the representation of the full climate divided into 9 wave classes in this study.
I could not understand what exactly because when you say morphic is different, if morphic is 2.5, that means it is 2.5 times of the total fancy.
Yes, sir. Yes,
Right,
sir.
even if you take 1 month or 1 year, it should be 2.5 times.
Yes,
So I'll take all the 9 elements and then multiply with that, I should get 1 at the end. If I take 1 year and then 1 by 9, same thing if I do. So, but anyway,
so those wave periods are again repeating. That is one cycle. That each wave class is again repeating with the one with each flow. Nine set of wave cycle. Again it is coming. Again it is running. So it is run so that it gives full the time period which has been taken. So that full those number of wave classes taken as inputs are repeating again and again till the time full year has been considered.
yeah, I will do the already explained. 110.
Many of them are read your question. Can you only the left side?
Okay, so there was one major question. See, if I look at the Kakinada Bay orientation, it is almost like north-south, right? And then you are saying southwest waves has an impact on it. If I say southwest waves are coming from the coast and going out into the other side, Burma, Myanmar side. How are they getting affected with Kakinada? That was the main question.
So the longshore sediment transport. So the waves are bringing the sediments, and then again.
Still, I don't agree with you because when you say southwest waves, where are the waves measured? If you measure in offshore, yes, you get. But if you say longshore sediment transport is coming because of southwest waves, I don't know. Both experts are here. Dr. Jana and Siva, they can very well answer that. Yeah.
The annual cost running an component with the cost orientation.
Okay. So that was one thing with the southwest monsoon, southwest waves. Okay. Bathymetry measurement, you already answered that. And then was which of these wave estimating method is recommended and why? That was the main question from my side. Because you had two different methods, and then which one is that you recommend for further studies?
So in this study, for my study, sir, I had done two. I utilized two methods: energy flux method and potential sediment transport approach. And in that, I had applied the seasons. So for my study, I had compared like which one is the appropriate method by shoreline changes and the Bryson's.
All things done.
Yes, sir.
Answer. This is better than this.
So PSTA with seasons has been the appropriate method for my study.
So you are being very careful. For my study, it is better.
Yes, this is
Not minimizing for
yes, sir.
Yeah.
Yes.
Okay. All right. Before I end, few more things. Two things. One is I need to know from your study what are your major drawbacks or limitations of this study that has not come in your presentation. Okay. And then what is the knowledge that this study has put into the literature? These two, if you tell, then I think these were the last things I wanted.
So the limitations of the study is so just for hundreds, so there can be much more time period that can be simulated with all the forcings in which some sediment along with sediments we can pollutant increase the change in the depth channel, change in the port city. These factors can also be included. Then the new study which has been analyzed is like how these long-term morphological developments can be studied by a normal student also like me with the limited resources using these model reductions, input reductions, and acceleration methods. And I have in the literatures I have included different methods for schematizing the input data, like morphological types, schematized waves, applicability of seasons is compared, morphological acceleration factors, and the comparison of three scenarios: model reduction, input reduction, and the climatic changes.
Okay, you want me to give your answer? I will say, yeah. So, to my knowledge, this is the first work which has touched 100 years of simulations. Okay, that's the one major thing which has come out. I think I have given in my report. I thought at least you will read that out. Okay.
It's nice.
Okay. And in terms of comparing the numerical models and the remote sensing output, so that's another major outcome of this. In terms of limitations, your models have limitations, so that adds up to your work. Your remote sensing has limitation, that adds up. So these are the things as an examiner we like to look whether you are considering that or not. With this, I stop my questioning and then leave the questioning to the floor.
Thank you, sir.
Katrina?
No, it is, I'm happy to see a final outcome of this study.
Thank you very
I was
much.
there from beginning as a DC member.
Thank you very
I
much.
think long-term serving DC member for assist from beginning to end. So it came very well after a lot of struggle.
Yes, thank you very
And
much.
so with this, and I about to ask that question Dr. Jayakumar has put. So what is that you are going to give this from your study to the future researcher? So that is the main important and what is spelled out here. Only thing I will ask only one simple questions for this. So you have added climate change.
Yes,
But say one extreme event happened there.
yes,
Whether what will happen to your inside wave? Now you have brought out you are going to have so much deposition and all.
yes,
Climate change also you studied.
yes,
Okay, one super cyclone came there,
yes,
which is having the super cyclone also all the direction are from southwest only, from south to
yes,
towards north. One cyclone have changed the direction from northeast.
yes.
So what will happen to your bay? Is there anything you can talk?
So, first of all, so the presence of mangroves. So mangroves are considered as barriers between the land and the sea, and it has been seen in various areas that these act as highly protective barriers against the cyclone and tsunami activities. So for the southern part of the bay and the western where the mangroves are there, so there will be larger impact would be offered resistance. So first of all, the city would become protected by the action of by the presence of the mangroves, the stabilization actions, and yes, that extreme study has not been followed in here, but yes, so there will be impact on the erosion of the spit in erode with the higher waves.
Sir, you can go ahead.
Yeah, Jayakumar has just an answer for what he had asked. Well, simple, one line. It's a limitation of the mechanism. The limitation of the screen.
I was asking indirectly. Yes.
You can't do that. Simple. Okay. There's a limit for the model simulation of the actual physics. Actual physics got so many parameters that you really don't consider. Simple sediment fraction. You might have taken one single sediment size. Actually, in nature, it has got so many like that. That's a minus limitation. What answer for Dr. Jain also stands.
That's all.
Anybody else?
I think anybody is online any black box you can see that you can close it. No problem.
From here, not necessarily to be too technical and even otherwise. As a community member, whether you feel that this work is somewhat relevant, or what is your opinion as a society member?
Can I, sir? With your
Yes, sir,
permission?
please.
Yeah, I don't know whether this question is relevant or not relevant. Probably the expert would say. How does the tsunami affect generally the morphological system of the coastal? No. I want to hear from the scholar.
So any tsunami activities, means higher wave action would be there.
There itself you are
there will be erosion, there will be destruction at the many areas. So that's why, like in this area,
No, technical. That all we read newspaper, we also know that. But from the research scholars, what are the real challenges in protecting the morphologicals along the coastal?
so the coastal.
It's a general one. Maybe it's not relevant to the topic.
Don't take it too technical.
Yeah, technical. Yeah.
So mangrove plantation, mangrove forestations, that would really,
We rephrase the question. Whether a tsunami will affect your study results.
Yeah.
yes, sir, it will affect.
It's an episodic event, and no episodic event can be predicted and factored in the correct timeline.
Okay.
In our 100 years prediction.
Because you said in the conclusion part C, can the climate change effects on the development of a bay be predicted by the long-term morphological model? Has it been considered?
Yes, sir. So the decadal sea level changes have been incorporated all the decades, and the third variant simulations, which was run for 100 years, that is the answer for that question. Climatic changes.
Climate change, what she means is sea level change.
Right.
That's how it is being interpreted here.
Maybe I may not be knowing too technical.
That's the difference. Like, say,
yeah.
for example, from outside, for us, we feel climate change, there are so many things.
Yes, sir.
Monsoon, erratic monsoon, all those things also climate variation only, but all those things are not seen here. Only MSL seen. That the MSL also is only predicted MSL.
Right.
Again, there's another limitation. We really don't know how the MSL is going to change. Last 10 years, understanding and today's understanding
It's
are very
completely
different.
Yes.
That time they are telling it's 1 mm per year. Now they are telling 2.5 mm per year.
Oh.
It is, I don't know whether it's getting accelerated really, or we are misreading it in the first place.
Okay.
Anything is possible.
I think instead of the scholar defending, the experts are defending everything. The guide is
easy part is done.
yeah.
Out of syllabus.
Out of syllabus. Yeah.
I'll just add to the tsunami part.
Yes, sir.
Tsunami is a surge.
Yeah.
It's increased water level, which will inundate for a longer period than a wave period.
Right.
So that will have a definitive morphological effect both near the coast as well as hinterland.
Right.
So that cannot be included into the long-term morphology changes.
Thank you very much. To the next.
Apology also.
Just elementary questions. Many questions are already being stolen from me. First one is why Kakinada Bay?
Yes, sir. So Kakinada Bay has a very unique morphology in which it is naturally formed in the past 150 years. Initially, it was a very shallow region where only during tides there used to be some water, and then slowly, with the change in the confluence of the Godavari River discharge, this spit was formed by the action of winds, waves, and all the sediments that have included. So its unique morphology, the way it was formed, and then the colonization of mangroves in it, the abundant lobe data. So seeing its past formation over 150 years, how it has been formed. So it's the morphology changes would be very interesting to know in the future also, that how the physical processes are affecting its formation, how it has formed, and how further it will lead to the further changes. That's why Kakinada.
Can we start with
It's a dynamic process.
4:30?
Can you tell me at least one novel outcome of your study, which you would say is the most important, adding knowledge to whatever is existing?
First of all, the exact the method, the process by which how this prediction can be done. It is done, but how it can be done in inclusion of so many factors, inclusion of different processes, the comparisons, how the representative inputs are formed, that is how acceleration factors are formed, how it is validated, like morphic for tides is different, and variable morphic for waves are different. So basically the methodology is very unique. It has been formed step by step. So that is the new introduction which I can say for the overall study. And how
You mean to say there are no studies?
so there have been studies, but the integrated studies, the comparison of numerical models. Yes, the comparison of integration of two techniques like remote sensing, GIS, and numerical modeling. That how we are, how I have validated the data, the past data. So it's integration of two techniques.
You mentioned in the end that conservation measures for predicted endangered ecosystems can be well planned. Can you give me an example?
Yes, sir, definitely. So, like now, for any study, if we show, okay, after 100 years, this would happen, or after 10 years, 20, like whatever the time period of study is. So, if at some place we can see that erosion is going to form, or some kind of climatic change, or that would affect the city. So, accordingly, construction of like some wall structures, barriers, plantation of mangroves, these can be done so that impact of various factors, high waves, tsunamis, etc., can be prevented like this. So these can be the conservation methods and planning management. So if somewhere more soil erosion can be done, accordingly some breakwaters can be formed so that city is not directly impacted by the higher waves, like it has been done in the case of Kakinada, that breakwater has been constructed. That will be viewing the higher impacts so that the port is not affected. Like this, these studies will help in conservation and further planning management. Okay.
Thank you.
Thank you.
Yeah, Garima, you made a good presentation,
Thank you very much.
nearly about a decade period. Congrats. This, if you get a chance, what could be the next bay instead of Kakinada?
San Francisco.
Have any idea?
So maybe we can study Sundarban deltas, because the impact of cyclones is very much there, and Odisha also. So because Odisha is the most affected region, Uppada region, these are the two majorly affected regions because of the cyclones. And we always see every year when cyclone comes, Odisha becomes the most, Gopalpatnam, these areas become the most highly affected areas. So maybe study can be done on this, that some measure conservation methods or planning measurements can be done so that these areas are not affected and the population is not affected as badly, as severely as it is always. So,
Okay, you used a Delft 3D model.
yes, sir.
So, what is the latest version of this?
So it is 4.3.
Any other alternate for this?
Definitely. So we have, like Mike, we have.
Why have you chosen this, particularly this Delft 3D?
So because Delft 3D includes all these modules in which morphological predictions can be done. There are different modules in this, and it is like it includes basically the morphological modeling changes can be done with using different modules.
Okay, how you made this validation? It's a numerical and this.
Satellite imaging. Yes.
Validation is matching,
Yes.
no deviation.
So there is slight deviation, but the regression coefficient and the statistical parameters are reasonable. So that model can be seen, okay, it is reasonably validated.
In your report, you mentioned the references.
Yes.
How many references in the report?
So in numbers, there might be
By seeing the report,
more than 78.
it's not given.
Numbers have not been given, they are bulleted, but definitely some.
Oh, okay. Serial numbers of the references.
Yeah, overall performance is good.
Thank you very much, sir.
But the serial numbering is very important. It's very, very important.
That is required.
So the answer why you use Delft 3D is free. Open source.
Go to micro free or something, you will spend on crore.
Suppose we open source.
Models are commercially open source.
Yourself can write the program, then 3D is really available.
Yes. It can be correct for you. They give the source code. But source code is what you cannot compare in the Windows platform.
No. Now in the last 2 years they made it open.
Open,
teaching model, but the services want to go beyond past sense.
The things well, initially we are playing around 1.5 lakhs.
And it reading
Yes. So, if no other queries are there, can we join congratulating Mrs. Garima Sharma for having the doctorate? Yeah. Okay.
Thank you so much.
Yeah, on behalf of the examiners, and based on the defense carried out, yes, Garima Sharma has successfully defended our thesis, and with the power vested in me as an examiner, and with the consent of the guides and the university, we declare PhD for Garima Sharma. Congratulations.
Congratulations, Garima.
Thank you very much.
Thank you, sir.
Thank you, sir. Thank you very much.
That's right.